Okay, so now looking at page 35A, we're going to learn how to factor trinomials with two variables. So the way that I do it is I notice, look, we have an extra y and y squared. I'm going to rewrite it without the y or y squared. And now I'm just going to factor this. So this is going to be x plus 7 times x plus 2. Now, because I took out the y and y squared, I'm going to put them back in. Notice now when I FOIL this, I get x squared plus 2xy plus 7xy, which is 9xy. And 7y times 2y is 14y squared. Okay, so let's try that with another one. We have y squared minus 6yz plus 5z squared. So this time it's the z that's extra. So I rewrite it without the z. And I say this is y minus 5 and y minus 1. And so that equals positive 5 adds up to negative 6. So I have to add a z there and a z there, and I'm done. Because y squared minus yz minus 5yz is minus 6yz plus 5z squared. Okay, so that's how you handle double variables. Now, I want to go over the difference between a prime trinomial and one that can still be factored. So if we look at x squared plus 26x plus 8, and we ask ourselves, is it any possible way that the factors, okay, two numbers multiply to equal 8, but the same factors add up to equal 26? And that's impossible, because the only factors of 8 are 1, 2, 4, and 8. And none of them are going to add up to 26. So we would call this prime. But let's compare it to the next one, 2x squared plus 52x plus 16. This is not prime because I can take out a 2. Now after I take out a 2, I'm left with the same trinomial I just started with. So this trinomial is prime because there's nothing I can do with it. But this trinomial is not prime because I was able to factor out a 2. So don't confuse the fact that once you factor out the GCF, you can't factor it further. That does not make it prime. It's when you can't factor out anything that makes it prime. The last thing we're going to do is we're going to go over a type of problem that says, find all the values of b for which this trinomial can be factored using integers. So basically, it's saying what numbers, okay, if you could multiply two numbers and get it to equal 1 times negative 30. So two numbers that multiply to equal negative 30, but add up to equal b. So, what numbers multiply to negative 30 and add up to b? Well, negative 30 and 1 multiply to negative 30, and they add up to negative 29. 30 and negative 1 multiply to negative 30, and that add up to positive 29. Okay, I have negative 15 and 2. They multiply to negative 30, but they add up to negative 13. And 15 and negative 2 multiply to negative 30, but they add up to positive 13. Okay, let's see if there's any more. Are there other factors? Yes. I could do negative 3 and 10. I could do 3 and negative 10. And I could do 5 and negative 6 and negative 5 and 6. This adds up to positive 7, negative 1, positive 1. So my final answer is plus or minus 29, plus or minus 13, plus or minus 7, and plus or minus 1. So that's how you find all the possible values of b. You first find all the possible factors of negative 30 and see what they add up to.